I'm Anil Kumar, and now let us explore how to prove segment relationships. We are given segment AC congruent to segment BD. That's a sketch for you. Segment AC is congruent to segment BD. We need to prove that the segment AB is congruent to segment CD. Now, for any geometric proof, what we should do? We should adopt a formal method, and the best known formal method for us is the two-column proof method, right? So we'll make two columns and then try to justify each statement one by one, deriving the proof. So in this columns, we write statements on the left side, reasons on the right. And we should number each and every statement, correct? So let's start with statement number one, which is normally the given statement. We are given that the segment AC is congruent to segment BD. Reason given. Now, when the segment is congruent, that means their measurements are same. So measurement of a segment is written as AC is congruent to BD. That is the measurement of these segments. That means the length AC is equals to length BD. This we get from the definition of congruence. Now, if you look at AC, point B is in between. So we can adopt segment addition postulate. AB plus BC should be equal to AC. So that is the strategy. So in statement number 3, what we can do is we can write AC as combination of AB and BC. Okay. So that is how we can write AC, and this is equal to AC for us. And how do we get it? What is the reason? Reason is segment addition postulate. So this is the new postulate which you've learned in this chapter 2.7. So we are actually trying to see applications of this postulate. Now, can you tell me how we can write BD? BD can also be written as combination of BC and CD, right? And the reason is same, segment addition postulate. Let's combine this step with third itself. So we say, well, BC plus CD is also equals to BD, right? The reason is segment addition postulate, correct? So that is how we get these two statements. It's a good practice sometimes to combine similar statements, correct? Now what? We know that AB plus BC is AC, BC plus CD is BC. Now what is given to us? It is given that, sorry, I wrote this as C, it should be D, yeah. BC plus CD is BD, okay, it's BD. Let me correct it, okay, BD. But what is given to us? It is given that AC and BD are equal, correct? Since they are equal, we can actually write AB plus BC is equals to BC plus CD, right? And the reason is we combine 1 and 3. So that is from substitution. Of steps 1 and 3, correct? Now, what do we need to prove? We need to prove that AB equals to CD. So we need to prove that AB equals to CD. So we have something extra here, which is also common on both the sides. So if we take away BC from both the sides, what do we get? I think we get what we need, right? So we have AB plus BC. Take away BC equals to BC plus CD. take away BC, correct? So when we do this, what are we doing? And what is the reason of doing this? This is called subtraction property of equality. Now BC minus BC is 0, so we can write AB is equal to CD. So we are writing an equivalent statement. Whenever we do so, we should write substitution as our reason. Okay, so it's from substitution. And now if the measurement of these segments AB is equal to CD, then the segments themselves are congruent. You get it? If the measurement is same, then the segments are congruent. And that is what we get from definition of congruence. Hence we have proved that AB is congruent to CD. Go through these steps and try to understand how in logical steps we can conclude what we need to prove. And for each step we should be providing a reason. That's the beauty of geometry, right? I hope it makes things simpler and easier to understand. Thank you and all the best.